Hi, everyone. We'll just give it another minute to let everybody in from the waiting room, and then we'll get started. Okay. Good morning, everybody, and thank you for joining us for our webinar today, which is called Enhance Your Research with CAIR. My name is Melissa, and I'm going to quickly introduce our presenter before we get started. We're hosting this webinar today to mark Memorial University's Research Week, the goal of which is to celebrate and raise awareness of Memorial's internationally renowned research expertise and encourage more multidisciplinary collaboration among the research community. As we go through the presentation today, I'll encourage you to use the chat or the Q&A feature to ask questions that we'll address following the presentation. You may also wish to turn on captions by clicking the CC button on the bottom left corner of your screen. Our presenter today is Paul Price, and if I'm not mistaken, oh, there you are, Paul. I thought perhaps you might have had the fish tank view for our participants to enjoy. Paul is a systems administrator at the Center for Analytics, Informatics and Research, what we like to call CAIR, and what we used to call CHIA here in the Faculty of Medicine. Previously a systems programmer in the Department of Computer Science, Paul has over 20 years of experience working in IT and data centers at Memorial. Paul's interests include agent-based simulations and local cloud services for research. And Paul is known for his favorite quote around the office, which is, "There is no cloud, it's just somebody else's computer." So I'm going to hand it over to Paul to get us started.
All right, thanks, Melissa, for that. As Melissa said, I'm Paul here at CAIR. And I will start my slides. Oh, it's not at the beginning. Okay, so essentially this is just going to be a little presentation on our data center here and some examples of how it can be used to enhance your research here at Memorial. I also have some examples of researchers that are currently using it and what they're using it for. So I'll give a quick overview of the new hardware we have and then some examples of people using it. All right. So this is an actual picture of our data center on the right. It's a high performance computing center. It has the capacity to rapidly process and analyze lots of data. We have a secure enterprise storage, which we also do tape backups, and we do carry tapes offsite into a secure vault. The staff here at CAIR is we can assist researchers with determining best tools for analysis, troubleshooting any issues they have with those tools, or just general issues with accessing the data center. We can do secure transfer of data in and out and results out of the data center, and we can also do large data storage and backups for archiving or just general backups. So what is a HPC, or a high performance computing center, such as the data center we have here? So there'll be a little video here next to just do a little explanation over what HPC is and why it's important. That is incorrect. Okay.
Processing power is what differentiates supercomputers from general-purpose computers. Supercomputer architectures are made up of multiple CPUs that have thousands of nodes that use parallel processing to communicate with one another to solve problems. With this power, supercomputers can perform resource-intensive calculations that general-purpose computers can't handle, often for engineering and computational sciences applications, including oil and gas exploration, molecular modeling, physics simulations, nuclear fusion research, medical research, and cryptoanalysis, among others. Tech giant Meta is building its own supercomputer for AI research, supposedly to build new tech for the metaverse. Read more about it in the link above or in the description below. The first commercially successful supercomputer was Seymour Cray's Controlled Data Corporation 6600 in 1964, which could handle 3 million flops, or floating point operations per second. Basically, how many calculations a computer can solve per second. IBM's Roadrunner, launched in 2008, was the first supercomputer to break the petaflops barrier, clocking in at 1.105 petaflops. Supercomputers can now perform over 100 petaflops, aka 100 quadrillion operations per second. The fastest confirmed supercomputer as of 2021 is Japan's Fugaku, clocking in at 442 petaflops. The next big development in computing might be processing in the exaflops range, that is, a 1,000-fold increase from petaflops. Exascale computing could support new possibilities that transcend even the most modern supercomputers, like generating an accurate model of the human brain down to the neurons in synapses. Quantum computers can be used for similar resource-intensive research, but they're not the same as supercomputers. Quantum computers utilize quantum algorithms to solve equations, whereas supercomputers use classical computing. Also, the real-life applications of quantum computing are still limited, while supercomputers are already widely used for a range of business, tech, and research applications. What do you think? How else will supercomputers, perhaps those on the exascale, impact our lives? Share your thoughts in the comments below and be sure to hit the like button.
All right, so that's just a little explanation of, they're using the term supercomputer. We refer to it as HPC, or high performance computing. It's general overview of it, but you should get the idea. So we did refresh the hardware recently with a renewed partnership with IBM and also with Memorial and the government. So we did still bring forward some of the, I'll say, classic hardware to support some legacy stuff. So just a little explanation now of some of the new hardware that we have. So we have a brand new enterprise IBM storage. We didn't actually change the amount of storage that we have, but we had an enormous amount before. But what we did do is change its footprint, and it's new technology, and it's faster. It's about 6 petabytes of storage. So just to give an idea of how big that is, it'd be 6,000 terabytes, or like your classic laptop may have a 500 gigabyte hard drive. This would be about 12,000 of those hard drives would be the equivalent of the amount of storage we have. We had 4, let's say, full racks. That's about let's say 10 feet long and 7 feet high. We've moved it all into essentially 3/4 of one rack. So that's that reduces our carbon footprint, reduces the amount of cooling we need on this storage, the electricity we burn. Overall, the heat generated has been reduced. So overall, we've made great improvements in the storage area. The actual HPC cluster, or as the video referred to it as a supercomputer, we've have brand new 28 IBM AC922 servers. These are a different architecture than the classic, which was x86, which would be the same architecture found in your laptops. This is a power architecture, an IBM chipset that 28 of them. They have 40 cores each, and each of them has 256 gigabytes of RAM. So just to give an idea of the improvement or the change from the legacy hardware. So this is the standard configuration for one of our compute nodes now. 40 cores with 256 gigs of RAM. The original hardware, 256 would have been one of 4 computers that had what we call the large memory. So that would have been our large memory, and standard memory I think was 64. So just the memory increase alone on the standard is very significant. And as you can see, we have 4 new large memory nodes, each of them with 1024 gigabytes. So that's 4 times bigger memory storage on the large nodes, which we do get actually a fair amount of requests for memory when doing large HPC jobs. And the last entry here, which we're very, very excited about, is we're adding GPU, graphical processor units, to the HPC cluster. Now, if anybody played video games, you recognize the GPU as something that the video gamers always like to have in their computer for nice graphics. Well, it turns out that the GPUs are also really great at some math calculations and that, and they can really speed up some computations by a mass amount, which I'll give an example later about. But yeah, we got six of those. Each one has 4 Tesla V100 GPU cards in it. So it's we're very excited to have that and the ability to offer to our researchers to take advantage of it. Whoops, wrong way. So just a little explanation in this video on what a GPU is for anybody who's not aware, and its use in kind of research. The video is kind of more maybe centered around business, but you get the idea of some things that can be done with it.
Over the last decade, IT managers have leveraged virtualization and software-defined infrastructure to keep up with demand and support traditional apps. But times are changing. As AI and data science drive an exponential growth in compute demands, businesses need to embrace accelerated computing and transform the data center to meet current and future needs. Imagine training the next generation of recommender systems that will serve customers better, getting insights from petabytes of data in minutes instead of days, or detecting cybersecurity threats using artificial intelligence to monitor network traffic in real time. All of this is possible by upgrading your data center with NVIDIA-certified servers with GPU application accelerators and high-performance networking. NVIDIA has a wide portfolio of GPUs and networking products that are designed for...
Okay, I'm going to stop that there because the rest of the video is more NVIDIA advertisement. But you can see some of the ideas of how it improves, that using GPUs can improve our results and our insights and stuff. So in addition to the HPC environment or the supercomputer environment, we do have what's called a virtual machine environment, which is powered by OpenStack software. This environment is using x86 computers. We have 736 CPUs that are available and spread across multiple nodes that are part of the OpenStack environment. There's 2,300 gigabytes of RAM available, and the connectivity back to the enterprise storage. So all the hard drives for the virtual machines are stored on the enterprise storage, and our connectivity is 54 multiple lane 54 gigabit connectivity. So just to give an idea why that's important, standard Ethernet, high-speed Ethernet would be by 1 gigabyte. So we're not using that for the connectivity. We're using specialized in InfiniBand, Mellanox InfiniBand for the connectivity, and it gets us to a much faster speed. Pretty much you wouldn't notice that it's on the net. Essentially, it's networked. It would feel as if you were using a hard drive directly in your own computer. So on the next slide, there talk about just a few services and software that we offer as a service to researchers. So Aspera, which is a high-speed transfer package from IBM. We do get some requests for large amounts of data to be moved between like us and U of T or other universities, and it could take a long time to move the large amounts of data, like to 500 gigs or whatever they're moving. Aspera allows us to maximize the throughput on our connection and can cut down the time for transfer dramatically. The next three are really just some packages that are open source that are available to researchers, like TensorFlow, PyTorch, and then Conda is an environment that packages and different versions can be installed in. We are, open to working with any researcher on, different versions they need, or is it a different open source package, or if they have licenses that we can use for something that they want to run on our HPC or our virtual environment. By all means, we are open to discussions and trying to make that work for them. We have what's called a Nextcloud environment. The best way to describe that would be it's like Dropbox or Box, but it's hosted internally on our own hardware. And it's a great place for people, researchers, to essentially store data that they want to collaborate with either students or other researchers. The nice thing about it is that it comes with a nice web GUI interface, just like Dropbox would, and you can upload and share to different people through that. Another service that I mentioned previous is virtual machines, which is on OpenStack. You can request some hardware, some resources, like so many CPUs, so much RAM, so much storage, and we can create a virtual machine. It can be Windows or some Linux flavor, doesn't matter, and you essentially get control of your own virtual computer to do as you need. Some cases people have full access to do what they want, and they're essentially put in a sandbox for security reasons. There's other cases where we maybe might do the install and get the basics running on it, and then they just have regular user access to do what they need to do. Again, the HPC environment is there, which researchers can use for either large calculations or long-term calculations, or even short ones. Pretty much anything that they feel that they need to do on the HPC environment, they're more than welcome. Enterprise data storage, that's the 6 petabytes of data that I spoke about, which also comes along with the backup tape storage and archiving and offsites. And of course, just the whole nature of this kind of creates a data lab where you may have some research data that you can't, let students take home or take on their own laptop or whatnot. But by combining the virtual machines with the storage, they can kind of get in onto a machine with the software they need to do their analysis, or if it's HPC analysis, they can do it there. But the data itself always sits inside of our data center, and they can have access to do their analysis, and then just results only, if that's what's needed, can be transferred outside for publishing or whatever the next step may be. So the next part here is if you just want like an HPC account with us, pretty standard stuff. There's a link there for requesting a standard account. If you need support, you already have an account, need support, or you have general inquiries, or because the standard account link is so long, you can just email us at cair-support@mon.ca, and we'll be more than happy to help you. And if you have a bigger need for like some large enterprise storage or some dedicated virtual machines, you can still contact cair-support@mon.ca, or you can contact me directly. Of course, cair-support, I'm also in that list too. So you actually reach more people by using the mailing list, and it also includes myself. But by all means, feel free to reach out if you think any of this would be of help or interest to your research. So next are some examples. This is an HPC example from Dr. Andres in physics and physical oceanography. Her research focuses on modeling the periods of climate change during the past in order to better understand how our climate systems behave when the inputs are changing, like greenhouse gases, ice sheets, solar forcing, and volcanoes, and whatnot. So we are providing the HPC resources for her to model this climate change from vast amounts of data. There's also three pretty big packages, common packages for climate modeling that we have available on our system for anybody doing climate research or modeling can use. The next example is Dr. David Pike in mathematics and statistics. He has furthered his research in trying to establish existence of Steiner triple systems and that are uniquely four-colorable, and also in the area of computational design theory. And later, he has directly produced 3 papers from the research he has completed on our cluster. So we provide an HPC environment that allows them to run long-term jobs. So some of his jobs actually have been running for longer than a year. So that's, our system is up for a long period of time and quite stable. So he's run jobs for more than 1 year at a time. Another research project here at MUN, which is SurgeCon, which is a real-time analytics to improve healthcare efficiencies. So they gather information that accurately predicts surge levels, automate workflows, and implement proactive measures in the ER to improve patient outcomes. We are providing SurgeCon with a secured virtual machine environment to allow for the storage and analysis of highly sensitive quantitative and qualitative research data. Through this, it also provides support for other research initiatives such as the Rural 360 project, which looks to establish a rural learning health community in northern Newfoundland and coastal Labrador. The next two actually are using, I guess, the full gamut, the HPC, virtual machines, and storage. So the Center for Translational Genomics, CTG, we provide bioinformatic analysis, virtual machines, enterprise storage for locally generated sequencer data, and a web-based GUI for processing that data. And a quote from a bioinformatician about our storage is that CAIR's enterprise storage is like gold for genomics. So that's great to hear. Really, glad that they're really excited about the cluster we have and the storage. So Create, which I've listed as our lost sibling, or we are lost siblings. So we fall under the same umbrella here at MUN, and we've embarked on a partnership that will strengthen the research activities here at Memorial. So we're going to achieve this by sharing knowledge and our resources, and we will collaborate jointly on beneficial projects. And the first step that we took in that was CAIR storing data from the create network. So next, this is probably more complicated than I can explain. It's also not my example, but essentially a new type of neural network or multi-layer neural network that's very popular now is called transformer networks. So it can be, they've discovered that one time in neural networks they would have a different type for different cases like image recognition, translation, classification. Anyway, recently, I think it was 2017, that they discovered that attention is all they needed. And they've been pushing the limits as to the different problems it can solve, and it's become very powerful. One thing about it is that it tends to take all the problems and create them into math problems or floating point problems, which is very important because I will show you in the next couple of slides here. So essentially they deeply train the model, and then based on that they can give it a scenario, and it can give a very good approximation of an answer. So the reason I said that the floating point was important is because here you can see an example of using a transform on a MacBook Pro. It's an i9 with 32 gigs of RAM, so 8 cores. Nothing, nothing to shy about. But as you can see in the, I don't know if you can see my mouse, but right here next to the equal sign or dash, sorry, after these equals, it says that the steps are taking 387 seconds, 376 seconds, 370 seconds. If you come down here to using one of our Tesla cards, so remember there's 4 of these in each server. We have 6 servers, so this is using one card. You can see that the time increase, or sorry, decrease in each step for training is 13 seconds, 8 seconds, 8 seconds. So that's an enormous jump. And let's say one of the advantages is that GPUs are really good at floating point calculations, and essentially using the transformers essentially creates a lot of problems that are solved by converting it to a floating point problem. Here is another example from Dr. Trico. So this is essentially like a star birth, and how planets are formed and stuff like that. And there's a jet being expelled on the top and bottom. So this was rendered on our hardware, but essentially it's the same render that you could do on your local computer, but it is at the limit of what a single computer can do. Yes, it looks really nice the way it is. However, this is more of a bigger picture overview, and the kind of research they want to do is to kind of zoom in and look at what's happening on a lot smaller level, interaction and stuff. And in this case, essentially those data points can't be calculated on your home computer. This is where the HPC environment would be very beneficial. With a large memory, it would just be able to handle a lot more data points to allow you to take essentially different slices and zoom in on this to get more detail and to find out some pretty interesting stuff. Well, that concludes my talk, and thank you very much. Hopefully I've generated maybe some interest and maybe some questions that I can answer.
Thank you, Paul. Perhaps if you like, you can stop sharing your screen there. And before we get into the Q&A, I'll just mention that you can type your questions for Paul in the chat there, and I have some that have already come in directly to me already. What I'm going to do now is introduce Catherine Street. Catherine is the director of NL Support. And for those of you who don't know, NL Support is what we call a SPORE support unit. SPORE standing for the Strategy for Patient-Oriented Research, which is a Canadian initiative. NL Support is one of 10 SPORE support units across Canada that provide specialized services to researchers, patients, clinicians, policymakers, and others to conduct patient-oriented research. And so we are connected with CAIR in that the Center for Analytics, Informatics and Research actually supports the work of the NL Support Unit under the umbrella of our data platform and services core. So Catherine is the director of NL Support, and she and the rest of the team here at NL Support and CAIR have worked with plenty of researchers to provide some of this infrastructure technical support that Paul just discussed to enhance their research. And so Catherine's going to join us for the Q&A here now in case there are some, excuse me, research specific questions. So to get us started, Paul, I'm just wondering if you can talk a little bit about whether or not there are any charges associated for researchers if they want to take advantage of the CAIR facility.
Okay, there is, I'll say, a cost recovery model that we've been working on, and the aim is to not break the bank for people. So we compare ourselves to other cloud services like AWS, Azure, and we make sure that we come well under, and we do. We also for researchers at Memorial, if you want to use our HPC environment, there is no cost for that. So you can use the HPC environment at no cost. It's for virtual machine environments and large data storage. There would be a cost, but we like to think that it's nothing crazy, especially if you compare to if you had to go pay AWS for similar services.
And just to add to that, of course, by using the CAIR infrastructure, you also have access to the technical support from Paul and the team, and all the data is backed up. So using our services compared to, say, AWS or buying a server to put under your desk, they are different. We feel we provide the full package of support.
Yeah,
That's
we have
right,
value add.
Yeah, value add,
Value
that's a better way of putting it, yeah.
Value add for sure. And speaking of backups, Paul, you mentioned during your presentation that data stored in CAIR is backed up off-site. That's correct, right? It is off-site. It's not just a backup here, but somewhere else. So that, of course, if anything were to happen, those backups are safe in another location, correct?
Yeah, we have 2 vaults that are in a different building that we move tapes to. Okay,
that's great. If someone wanted to request an account for CAIR, what does that process look like? Does it typically take a long time?
No, the turnaround for that would be either day of or the next day, depending on what time of day you've submitted it.
Right. And you included in your presentation a link to where they could request access.
Yeah. If the link's too long, which it is, you can just email cair-support@mun.ca and we can fire a link back at you to fill out the form.
I'll actually put it in the chat right now for everybody, so that they can go to CAIR's webpage, which is housed right now under the Faculty of Medicine's website.
So if you requested resources other than just the account, it does take time to create those resources, but we do like to have quick turnarounds and be responsive. So we like to, get right on those and get things done.
So generally would the CAIR team, excuse me, meet with a researcher to discuss their needs and their research plans and ideas and see how you might be able to help?
Yeah, we can do that. Some researchers know exactly what they need, or they essentially they have a let's say open source product that states, this is the storage you need, this is the resources you need, and and one thing about all this environment, of course, is like in a virtual machine, like if you say, well, I want 2 CPUs, 8 gigs of RAM, and then you find out that that's just not cutting it. Well, it's really easy to increase increase that. It's not a full, let's go and install again on a new computer. It's very easy to adjust those resources.
Sure. I have a question from Omid. Omid asks, are we provided with the instructions to use CAIR? I'm not sure if he had previously requested an account, but he said, I didn't see any instructions on how to use and request GPU, memory, etc. So do you guys talk through that with researchers?
Yeah, so that's really new. So we are working with, creating essentially how-to guides and stuff to do that. But if anybody who has an account now, is wanting to use that and take advantage and wants to know how to run the LSF command, by all means, if it's not posted, then just email CAIR-support and we will give you the commands and work with you on getting it running.
Sure. A really good question here from Matthew. Matthew asks, can CAIR create and Memorial's ITS put together a resource guide for their services to help researchers orient themselves amidst all the options? He says, I'm thinking also of what was Compute Canada. There are lots of options, it seems, but not always super clear where folks should go for what. So I don't know if something like that already exists, or maybe if that's a note we should take.
It doesn't exist, but it's in the works.
Okay.
And Catherine has her hand up.
Hi, CAIR has a steering committee which actually does include membership from ITS, AceNet, which was part of Compute Canada. Compute Canada seems to be going through some changes at the moment, and Dave Miller, who has oversight of CREATE. And perhaps, Paul, we should suggest at the Oversight Committee meeting in December that we work together to create that guide and get it out to researchers across campus. We can actually say it came from a Research Week webinar, so they'll like that. So yeah, we'll take that back to make sure that we bring everybody on board.
Yeah, and I know ITS keeps asking, we don't know where to send people when they ask for certain resources. So it is a problem on campus that, we're all trying to solve. I think some of it though is just trying to figure out where everybody draws the line to as to who's going to handle what. So, we're trying to work that out. Hopefully it's a quicker rather than a slow process.
That's great. Matthew followed up with a comment to say that thinking of the rollout of Microsoft 365 and his role as a grants officer, having clear advice for researchers on where to go would be extremely helpful. So he thanks you for that, the work that you're doing to try and put that resource guide together. Let's see, I'm just going to scroll back through the chat here a little bit. This is a good one. With the move to remote working, is it possible to connect to CAIR from off-campus locations? Or do you need to be in Newfoundland and Labrador or Canada, North America, or can you connect from anywhere in the world?
So I actually didn't have in the slot anywhere that we do run a VPN service that you can connect in to our data center. Right now, it's open to North America. If you were traveling somewhere that's not North America and you want to connect back, best bet is to give us lead time so we can make arrangements so that you can get back in.
And Paul, it'll be best if people are able to give us a static IP from wherever they are in the world, preferably in advance of getting there if that's possible, so we can do those arrangements with ITS, because we have to work with ITS to get that little bit opened up for us. And I'm not technical.
Yeah, that's correct. Right now, that's how it stands. But we're hoping that this process will be changing in the near future and it'll be a lot smoother. But yeah, right now, ideally, before you go somewhere outside North America, if you could give us a static IP of where you're going and a time frame, that would be the ideal scenario.
Certainly. Okay, so I have one more question here. So I'll just put it out there now that before we clue up, if you have any burning questions for Paul or Catherine, feel free to put those in the chat. And if you're not quite ready with your question yet, we'll provide email addresses. You can send them along after the webinar if that's easier for you. So that would be the last call for questions, I guess. Let's see. I think there's still one more. Oh, yeah. Can you briefly describe CAIR's security arrangements? You know, there was a recent cyber attack here in Newfoundland and Labrador with our healthcare system, and so researchers are more aware of those types of security concerns.
Yeah. So VPN, like you say, is open to North America, but other access, like different services, usually is very locked down to a certain port coming from maybe a certain geolocation or a certain range of IPs. And even inside the VPN, we do groups inside VPN. So when you connect, depending on what group you're part of, that's the access you will get. We have a new firewall going in place, and when we put the new firewall in place, we are also turning on two-factor on the VPN, so that will add another layer of security. So also, if you had a, let's say, virtual machine, and it's the only resource that you're using from us, and you want to have internet access on it, or like a web service on it, then that essentially would be sandboxed inside our data center, and the only paths it would have would be out to the internet and back in. So if it got compromised, it would be essentially inside its own virtual network and sandbox, so that the only thing was compromised was that one box. It can't walk around anywhere or go to the rest of campus. There's also multiple layers of firewalls and different services provided by Memorial that also filters different attacks and packages that may be sent.
Perfect. Wondering now if either Paul or Catherine have any, concluding comments that you'd like to share. You saw Paul gave some examples of research that has been. Paul has a fish tank in his office, everybody, and of course, being the tech guy that he is, he has a camera hooked up to it so that he can switch views during boring WebEx meetings, probably. Just to give everybody a smile. So please enjoy this view of Paul's fish tank. But what was I saying? Oh, yes. So you saw from Paul's examples that there's research from all different fields, different departments, different areas of expertise. So just because CAIR is housed in the Faculty of Medicine, it doesn't mean that health research, or because we're part of NL Support, which focuses on patient-oriented research, it doesn't mean that research in the area of medicine or healthcare is necessary to utilize the services at CAIR. It is open all over campus, correct?
It is, yep. Any researcher at Memorials, if we can support them, then we're very happy to do so.
And we should also emphasize that part of the funding that supports CAIR and the staffing of CAIR actually comes through Dr. Terry Tricot as principal investigator within computer science, with the co-investigators being Matthew Hamilton and Kartik Papuri. So through those relationships with computer science, we're trying to really enhance the user base of CAIR, and from there, as Paul has said, open up services across the whole of campus, and not just St. John's campus, that also includes Memorial. So it also includes the Grenfell campus as well.
Great. I'll just remind everybody that I posted earlier in the chat an article from the Gazette that talked a little bit about that partnership renewal that happened earlier this year. And if you read that article, you can learn a lot more about Dr. Tricot's research as well in the Department of Computer Science. So I am not seeing any further questions from our audience. So at this point, I'd just like to thank everybody for joining us this morning and for staying on throughout the whole session and being engaged and asking some of those great questions. We're really happy to share this information, and we hope to spread the word about the Center for Analytics, Informatics and Research, which is a mouthful, so feel free to call it CAIR. And please make sure to tell your researcher friends all about it. And if you have any questions, the last thing I'll do is type Paul's email right there in the chat quickly. Sorry, Paul, yours is the easiest one to remember. So
That's
that'll
okay.
be the one that we end on. And Paul and the team at CAIR would be more than happy to get you sorted with any questions that you might have. So again, thank you, everybody, and please enjoy the rest of your day.
Thanks, Melissa.
Thank
Thanks,
you.
Paul. Bye.